Hello and what's up, everyone? Today we are going over our Unit 4 Test 1 review. So let's get started. We're going to be talking about volume and surface area problems here. So the first one, it says a rectangle ABCD is rotated about side AB. That's our bottom side here. And if it's rotated, remember whenever we think of rotation, we should think of a circle, which means that on the two ends of this, we're going to have these circles that look like this, let's say, right? They connect, something like that, right? And this is our rotation. This is a cylinder. I know my picture is not drawn well, but trust me, this is our circle, right? Actually, let me redraw this. There we go. So let's say this is our circle here, right? With this circle in mind, we need to figure out what's what here. So we know that this creates a cylinder, and that's what this is asking. It's asking for the volume of that, right? So now we have to connect these pieces. We know that the radius of this is technically going to be that AD right here. So it's going to be 8 inches. The distance here, or the height of this cylinder, is going to be the AB distance or DC distance, right? Same thing, which is 12 inches. So now we have to find the volume of this. And our volume formula for a cylinder is pi r squared times the height. We know for pi, we can substitute that out for 3.14. My r is going to be that 8 squared. And then my height is 12. And once again, remember, Desmos.com, scientific calculator, the best tool that you could use, because we could type this right in, 3.14 times 8 squared times 12. And that's going to give me 214. Oh, just kidding, guys. I forgot to read this last part here. Right here, the answer should include pi. So we actually want to go reverse. We don't want to have this here. What we want to do is just have this pi symbol out here. We're not going to use the 3.14 here. So we just have to do 8 squared times 12. That's what we need to do. And that's going to give me 768. So our final answer here would be 768 pi, right? So see how we didn't multiply the pi out. We're just leaving the symbol almost like it's a variable like x or y. There's our answer. Next one. This one's only asking us what the diameter of this sphere is. Now, we have to remember that the diameter is the whole way across this circle or sphere here, right? So we know that half of this is 7.5, and that's our radius. We need to multiply that by 2, which is going to give me 15 centimeters. And that's it. The diameter is 15 centimeters. This problem was super easy. We just need to know the difference between our diameter and our radius. Now, if you're given the diameter and they ask for the radius, maybe in a formula, you have to divide it by 2. So keep that in mind. Next one, it says find the volume of the sphere. Your answer should include pi. Once again, we do not want to multiply by that pi. So what do we have to do? Let's just plug everything in. We already have our radius, so we can say 4/3 pi. My r is going to be swapped out with 7.5 cubed. So really what I want to do is 7.5 cubed. Let's do that first. Oops. And that's going to give me, whoa, back it up. That's going to give me 4/3 times, and I'm just going to swap the pi and the multiplication here around. 421.875 pi. Now we have to multiply my 4/3 and the 421. We do 4/3 times 421.875. And when we do that, actually going to give me a pretty nice number. going to give me 562.5 pi. And there we go. Nice and simple. We got the volume of this sphere. Next up, it says, a student translated an isosceles triangle diagonally in space to form a solid. Which shape are the lateral sides of the solid? So if we think of a triangle, almost like this, let's say that's my triangle, and we translate it diagonally, let's say next one's up here, our sides are going to look like this, right? Now, if it's in diagonal space, we could think of these sides, maybe this is one of the sides of the triangle, we translate it up diagonally, it's going to look like this. Now, if these triangles are congruent, which they should be because we're not changing the shape of the triangles, we know that these sides are congruent. And then if we move the whole triangle the same distance, these sides are congruent. So what we're given here is what we call a parallelogram. And there we go. We answered the problem. Next up, it says a frozen yogurt cone has a height of 24 centimeters. The diameter of 12 centimeters. A scoop of the frozen yogurt sits on top of the cone. The scoop is a sphere with the diameter of 12 centimeters. If the entire scoop of frozen yogurt melts into the cone, will the cone overflow? Show all of your work and explain your reasoning. So what we need to do here is find the volume of the cone and then the volume of the sphere of that frozen yogurt scoop. First, let's do cone, right? So the volume of the cone formula is V. And we're going to do all these in terms of pi also, just so we don't have to multiply out by pi. Is V equals pi r squared, or sorry, 1/3 pi r squared times h. So let's get our units. This is the height of the cone is h equals 24. And then the diameter is 12. But if the diameter is 12, that means our radius is half of that, which is 6. Let's plug this in. We get V equals pi, 1/3 pi 6 squared times 24. We could simplify this a little bit. We get 1/3 times pi 36, which is 6 squared times 24. And then let's multiply my 1/3, my 36, and 24. So 1/3 times 36 times 24. That gives me 288. So the volume of the cone, is 288 centimeters cubed. So if the ice cream that melts, the volume of the sphere, is more than 288 centimeters cubed, then the ice cream cone will overflow. If it's less, we're good to go. No overflow. So let's see. Scoop, we'll call it. Scoop. Change colors here, though, so we know that what we're doing. Purple. Scoop. Right? So the scoop, the volume of the scoop equals 4/3 pi r cubed. So what's the radius of my scoop? It's also 6. So let's plug this in. And once again, we're going to keep it in terms of, oh, I forgot my pi symbol down here, guys. Whoops, I'm so sorry. This is 288 pi centimeters cubed. I'm so sorry because we didn't multiply by the pi. We multiplied 1/3, 36, and 24. I apologize about that. So we get 4/3 pi times the 6 cubed. So what we need to do is, what is 6 cubed? 6 to the 3rd power is 216. So now we have 4/3 pi 216, and we can multiply 4/3 times 216, which will give me 288. And we might notice something here. Gives me 288, which is exactly the same. So no, they will not overflow because they are the same volume. They will not overflow because they are the same. Ooh, volume. Exclamation point. Be dramatic. Cool, there we go. We answered our problem. Next up. This one we actually gave you the answer. It says the figure illustrates an informal argument for the formula for the area of a circle. The circle is divided into congruent sectors. The sectors are rearranged to form a shape that resembles a parallelogram, as shown. So if you look down below, you'll see that shape down here that almost looks like a parallelogram. As the number of sectors increases, the rearranged shape more closely resembles a parallelogram with the area A, given by the formula A equals base times height, or base and the height are of the parallelogram. So what we could say is that the base, or it says what is the base of and the height of the parallelogram. That's what they want to know. The base of this parallelogram is going to be our circumference, or pi times r. And the height is going to be our radius, so r again. But realistically, the area of this is really just A equals pi r squared, which is the area for our circle. Because in other words, if we break this down, it's pi times r, which is really just like the base, or b. Sorry, let's make it small b times h, when b equals pi r and h equals r. Basically, that's what's going on here. But in other words, this is your answer right here in that red. You don't have to do the other green stuff. Let's not need it. Next up, let me switch my color back. It says the figure shows the design of a greenhouse with a rectangular floor. The front and the back sides of the greenhouse are semicircles with a diameter of W. The roof is a half cylinder. Consider the greenhouse with the floor dimensions width of 32 feet and length of 18 feet. A concrete slab 6 inches deep will be poured for the floor of the greenhouse. How many cubic feet of concrete are needed? So if we create a slab here, see this red piece is my slab. It looks like this, right? We now have a new dimension, which is this line here, which is going to be 6. My W is 32, and my L is 20 or 18. So what we have to do in order to find this, very simple, just multiply them all. So we do, because the volume of a rectangular prism is length times width times height. So when we plug those in, we get 18 times 32 times 6. Oh, just kidding. We need to be careful here because these are in feet and we're given inches. So we need to convert. We'll convert our 6 inches into feet. 32, 18 will stay there. And how many inches are in a foot? It's 12. So this is really like 0.5 feet. Got to be careful with that. So it's really like times 0.5. So when we multiply this, we get 32 times 18 times 0.5, which is going to give me 288. 288 cubic feet. Feet cubed. Part B says the cylindrical roof of the greenhouse will be constructed from aluminum. The aluminum costs $4 per square foot. What will be the cost of the minimum amount of aluminum needed to construct the roof? Give your answer to the nearest dollar. So, since this greenhouse, if we're covering this in aluminum, that's going to be our lateral surface area. But this is the lateral surface area of half a cylinder. So what we could do is find the lateral surface area of a cylinder and then cut it in half. So in order to do that, our volume or our area, our lateral surface area, LA, for a cylinder is 2 pi RH, right? And they wanted this to the nearest dollar. So first we have to find it out, find our the half of this lateral surface area, and then we could multiply it by the $4 per square foot. So let's plug in our information. We know that our radius will be half of this width, so it's going to be 16. So we're going to say 2 times 3.14 times 16 times 18. And when we multiply all of this, we get 2.14 16 times 18. We get 1,808.64. Now we need to divide that by 2 because we're not dealing with the full cylinder. So once again, we write that volume. 1808.64, but we want to divide this by 2 because we're only dealing with half of the cylinder. We only want half of that lateral area. Which is 904.32. But this is only the lateral surface area of what's going to be covered here. Now we want to say how much will it cost. So we multiply this by $4. Which is going to give me a final answer here of 3,617. And it says, give your answer to the nearest dollar. So that's where we're going to round off because it's 28 cents. And there is our answer. Here's the 2 answers to these problems. Awesome. A lot of work, a lot of thinking, but we got to the answer. Next up, it says US coins are roughly the shape of cylinders. Therefore, the formula for the volume of a cylinder can be used to compare the volumes of coins. How does the combined volume of 6 pennies compare to the volume of a presidential dollar? So let's first find the volume of a penny. So let's say penny. Volume. Remember our volume of a cylinder is pi r squared h. So pi r squared h. And once again, we're not going to multiply by pi here because we don't need to. Right? So what we could then say, actually, we might need to because they want to know by how many cubic millimeters. So we're just going to multiply everything out. So the radius for a penny, r, is going to be half of 19.05. So let's find what that is. It's going to be 9.525. My radius is equal to 9.525. And the height, h, is 1.55. Whoops. Figures don't know what they're doing. So we can now solve this. So we get 3.14 times 9.525 squared times 1.55. And we put this in our calculator. And we click enter. And we're going to get about the volume will be about 441.56. But we want to know for 6 pennies, right? 6 pennies. So times 6. Which will give me, 2,649.36. That's for my pennies. Now we need to do, which let me switch colors, our presidential dollar, which is just a dollar that's a coin. So it's a coin version of the dollar instead of paper. Now, the radius of this is going to be half of 26.49, which is 13.245. And the height is 2. So we can plug it into the same formula as over there, which is V equals pi, which is 3.14, times my radius, 13.245, squared, times the height, which is 2. And we can plug this into our calculator, 3.14 times 13.245 squared times 2. And we get the volume equals 1,101.7. And for our first problem, we want to multiply it by 2. So what we know, actually, we can answer this first bullet point here. It says, is the volume of 6 pennies greater or less than the volume of 1 presidential dollar? We could say, hey, look, 2,649 is for 6 pennies. 1 presidential dollar is 1,101. So it is greater. And by approximately how many cubic millimeters? If we subtract those two. So if we do 2,649.36 minus 1,101.7, we get 1,547. 1,547.66. But the original question up here is the volume of 2. So we multiply this number by 2. And we get 2203, 2,203.4. So the 6 pennies are greater. 6 pennies is greater. And there we go. We answered all the questions here. Last problem. It says we have a cylindrical container used to fill rectangular prism fish tank. So fish tanks are usually big giant rectangles. A cylindrical container, aka a cup or a bucket, we want to fill it. We want to say how many is the least amount of full cylindrical containers needed to completely fill the fish tank. So first, we need to find the volume of both. So let's do the fish tank. Fish tank, which is a cylindrical prism. So the volume formula is length times width times height. So we plug in our numbers. The length, let's say, is 12 times the width, 24, times the height, also 24. When we multiply all this, we are going to get 12 times 24 times 24 is 6,912. Whoops, sorry about that. 6,912. Inches squared. So for our cylinder or our cup, one thing that we need to make sure we have is we made a mistake here. These shouldn't be centimeters. This should be inches, right? So that we could continue this problem. So let's say cylinder, right? Volume of the cylinder, like we've been saying, equals pi r squared h. We can fill things in. We get 3.14. My radius is 5. My height is 8. So once again, let's plug it right into a calculator. 3.14 times 5 squared times 8. Click enter and we get 628. So now, how do we find out how many cups we need? Well, we could divide the fish tank measurement by the cup measurement. So we're going to say 6, 9, 12 divided by 628. And that's going to give me about 11 cups. And there's our answer. Awesome, awesome work. And that is our final answer. I hope you guys learned something from this review. Don't forget to check on it while you're taking the quiz. And until next time, peace.